All right, we're going to continue our discussion on chapter 5. Let's take a look at some of these functions and write down the appropriate name next to these. The first one that you see here is f of x is equal to x to the power of b. So the first one is f of x is equal to x to the power of b, where b is a constant, could be any number. When you see a function like that, or sometimes you see like y is equal to like x to the power of 2, that would be an example of that. This is known as the power function. The power function is like when you have a variable like x to the power of some number. Example, y is equal to x to the power of 2. That's the power function. The next one, if b is 1 over n, if this b here is a fraction, 1 over n, for n is greater than 2, then this would be known as the root function. So far we have two names, power functions. Now we have root functions. So the root function looks like f of x is equal to x to the power of 1 over n. Anybody remember what x to the power of 1 over n is equal to in terms of radical? Okay, recall. If I have nth root of x to the power of m, anybody remember how to write this in exponential form? X to the power of what? M divided by n. Make a note of that, please. So when we're talking about the nth root of x to the power of m, that is really is x to the power of m over n. So when we're looking at x to the power of 1 over n, we're talking about the nth root of x to the power of 1. So this is really is f of x is equal to nth root of x. So that's why they call these root function. This is just a name correspond to these. This is another fact that you want to include in your summary. If I have f of x equal to x to the power of p over q, p over q is the lowest term. Once you reduce that to its lowest term, if p, the number at the top of the fraction, if I have f of x is equal to x to the power of p over q. If p is odd number, the domain is all real numbers. We're going to look at some examples of that. Just for right now, we're going to write these facts. If q is even, the domain is all non-negative real number. It has to be positive numbers. We're going to look at some examples and graph of these. Here we want to graph f of x equal to x to the power of b, where b is equal to 0.3, 1, 1.7, where x is greater or equal to 0. So we want to see what would be the effect of b on the graph. If you actually graph these on your calculator, you would see as you increase b, as larger value of b cause the graph f to increase faster. So as you can see, as I increase these values of b from 0.3 to 1 to 1.7, you're going to make this to increase a lot quicker. So let's take a look at these examples. You should be able to, in this section, simplify each expression. We're going to use that, we'll do it by hand. So the first one is 16 to the power of 3 over 4. Now, remember, there's one relationship that you have to put here. Nth root of x to the power of m is equal to x to the power of m over n. You really need to remember this one. So what we have here is the number at the bottom of the fraction, n, is actually your root. Remember that. So if I have x to the power of m over n, this number at the bottom of the fraction is always the root that we're talking about. So in this case, your root here is 4 then, right? So that would be the fourth root of 16. Now this 3 could go right on included with this 16 or write it outside that. So in other words, I can write this as, if I have nth root of x to the power of m, I can write it like this. That is the same as saying that nth root of x and then raise it to the power of m. And this is really important for you to know that this m, this exponents could be outside or inside under this radical. So in this case, we're going to put it under the, we're going to move it away from this radical. Why? Because I know what the 4th root of 16 is before I raise it to the power of 3. What is the 4th root of 16? Yeah, you're looking for a number. When you multiply by itself 4 times, give you 16. It's 2 times 2 times 2 times 2. So therefore it's 2. And then I'm going to raise it to the power of 3. This whole thing would be equal to 8. Next one is the root is 3 and the exponent is 4. So if you recall here, this would be m over n. So in this case, we're looking at the cube root of negative 64. That's perfectly cubed. It means I'm looking for a number when I multiply by itself 3 times, I get negative 64. And that is what? Negative 4. Negative 4 times negative 4 times negative 4 give you negative 64. So this portion would be equal to negative 4. And then I'm going to raise it to the power of 4. I get 256. Next one, we have minus 125 to the power of 2 over 3. Remember that your root is 3, the number at the bottom of the fraction. So we're looking at the cube root of minus 125, and then we're going to raise the result to the power of 2. Minus 125 is also perfectly cubed. We're looking for a number multiplied by itself 3 times to give you minus 125, and that is negative 5. Negative 5 times negative 5 times negative 5 is minus 125. And then I'm going to raise it to the power of 2 again, plus 25. So all these examples here are purposely selected that be a cube of something or square of something, so you can see how that gets simplified. Use positive rational expression to write each expression. So what we want to do is make sure that all the exponents are positive. We're going to assume that variables are positive. First one, we have square root of x. Again, I'm going to write down the property that I need to know. If I have nth root of x to the power of m, that is the same as x to the power of m over n. Remember that. And that this m could go outside this radical. So the first one would be x to the power of my root here is 2, my exponent here is 1. So it would be x to the power of 1 over 2. Simple as that. For part B, you have cube root of x to the power of 2. So the number goes to the bottom of the fraction would be 3. The number goes to the top fraction would be 2. That would be x to the power of 2 over 3. See that? This number at the bottom of the fraction would be your root. So your root would be this number here, and this number goes to the top of the fraction. Next one, you have 4th root of z to the power of negative 5. So z to the power of 4th root of z is z to the power of 1/4, and then raise it to the power of negative 5. So it would be z to the power of negative 5 over 4. You want to have everything positive, so I have to move it. Remember, a to the power of minus n is equal to 1 over a to the power of plus n. You have to move it to the bottom of the fraction to make it positive. All right, next one we have cube root of y and 4th root of y inside the square root of the whole thing. So if you recall, just this portion here, that is the same as x to the power of what? This is 1. The root is 3. So it would be, not x, y to the power of 1 over 3, right? Just this portion here. If I have 4th root of y, what does that equal to? Y to the power of 1 over 4. Very good. And then if I multiply this together, then I need to use this property to add them. Remember, you add the exponents when you multiply. Okay, we're going to use all these properties to simplify this one. So this one here would be y to the power of 1/3. This would be y to the power of 1/4. The whole thing would be to the power of 1/2 because see the root here is 2. This whole exponent raised to the power of 1. So now in order to combine this, I need to add the exponents 1/3 plus 1/4. We know how to add 1/3 and plus 1/4 by now, right? LCD 4/4, 3/3. So it'd be 4/12 plus 3/12, 7/12. There you go. Y to the power of 7/12, then raised to the power of 1/2. You multiply this. Now, next property we need to know is a to the power of n to the power of m. You multiply the exponents. All the property we learned in past going to come to place here. So this would be 7/12 times 1/2 give you y to the power of 7/24. As you can see, the exponent is positive, so I don't have to move them around. And we should be done here. Make sure it's reduced. Modeling the length of a bird's wing. Just a good example to actually use one of those functions that you have in your graphing calculator. The table lists the weight W and the wingspan L for birds of particular species. So here they're giving me W be 0.5 kilogram all the way to 3 kilograms, and the L goes from 0.77 all the way to 1.4. Use power regression to model data with L is equal to A times W to the power of B. We're going to graph the data and the equation. We're really going to use our calculator to find all that for us. And then for part B, we're going to approximate the wingspan for the bird weighing 3.2 kilograms. And like I said, that's all you're going to do is input this data on your calculator and then let X be the weight W and Y be the length L. We're going to enter the data and then select the power regression. And this is for TI calculator. You should look for this. And you click on the calculation mode, CALC, and then look for this function here, power regression, as shown down there. And once you do that, voila, you can see the coefficient of A and the exponent B is given to you in one shot. And so now I got my equation right there. Y would be about 0.9674 times x to the power of 0.3326. We did all that, all those from our calculator. And so L would be approximately, I'm going to change Y to L and X to W. And as you can see, the calculator will graph that for you and find all the data that you need. So for part B, it says if the bird weighs 3.2 kilogram, this model predict the wingspan to be, so that's all we do, just substitute the numbers. You would substitute the W 3.2, and then you would get the result about 1.42 meters. As you can see, all these data are available on your calculator. These are the functions that you want to include in your summary sheet. Root functions. We talked about root function. We're going to have f of x equal to nth root of x. Now, if n is even, this is something that you want to include in your summary sheet. Now, if n is even, so if there's a second root or fourth root and so on, as you can see, the graph would look like this. Starts from 0 and then increases. This would be y is equal to square root of x. You can graph all these three on the same screen on your calculator to see that. If you have y is equal to fourth root of x, the graph is not going to be as sharp as the y is equal to square root of x and so on. And then, as you can see, the domain would be from 0 to infinity. Domain exists, domain's a value of x, from 0 to infinity. And the range also would be from 0 to infinity. These are the points that you want to make here on your summary sheet. For n is even, as you can see, the function is increasing from 0 to infinity. And this is a continuous on 0 to infinity. There's no poles or point of discontinuity here. When n is odd, and you can see the graph goes from negative infinity all the way to positive infinity that way. And you can see how that behaves as I increase the roots from 3 to 5 to 7. It affects the graph this way. And as you can see, the domains from negative infinity to positive infinity, so as a range. So if n is odd, the function increases from negative infinity to positive infinity, and also this is a continuous function in that range and the domain. Find the domain of each function. Then somebody asks to find the domain, they want to see the restrictions, if there is any restriction exists in your equation. The restriction appears when you have something under the radical, when you have a variable under the radical, like x. So what would be the restriction here, anyone? If I have y is equal to a square root of x, what would be my restriction? X has to be what? Positive, right? Cannot be negative. So x has to be greater or equal to 0. That would be my restriction. You cannot have a negative. Yeah, if another restriction appears when the variable goes at the bottom of the fraction, like 1 over x. So what would be restrictions here? X cannot be equal to what? 0. So there are two things that you really look for when you're looking for a domain. You want to make sure that if your variable appears under the radical or under the denominator. So in this case, both of these, we have variables under the radical. So 4x plus 12 then must be positive number, has to be greater or equal to 0 for part A. So 4x plus 12 is greater than 0, and so for this x has to be greater or equal to negative 3. This is my restrictions for that. So the domain would be all the number from negative 3 to infinity if you write an interval notation. How about the second one, part B? Is there any restrictions here? What's the difference between part A and part B, anyone? The root one is even, the other one is odd. Remember when we looked at the graph of odd root? That covers the entire graph, right? All the way from negative infinity to positive infinity. So there were no restrictions that exist. So if its n is odd, there is no restriction. Your graph, by looking at the graph, you can see the graph goes all the way from negative infinity to positive infinity. So your domain would be all real numbers. The only restriction that we look for is when the root is even. If the root is odd, look at the graph of that, use your calculator, you can see the graph would cover everywhere from negative infinity to positive infinity. It's always going to be all real numbers, exactly. Explain how the graph of y is equal to square root of 4x plus 12 can be obtained from the graph of y is equal to square root of x. So this is like a shifting method, but it's not a very obvious shifting one. You have to do some simplification here. Can I make y is equal to square root of 4x plus 12 somewhat look like y is equal to the square root of x? I can if I factor some numbers under this radical. If I go ahead and factor the 4 under the radical, you can see 4 times x plus 3. And I can separate this. Recall if I had square root of x times y, I could separate this to the square root of x times square root of y. So I can write this as square root of 4 times square root of x plus 3. Square root of 4 is equal to 2. So now I can see how it's shifting because we have x plus 3. This is like really is x minus 3. So your shift would be to the left 3 units. So you're shifting to the left 3 units. And this 2 would tells me that the graph is stretched vertically by the factor of 2. So at the first, it wasn't quite obvious that this can be graphed by using the shifting method, but once we go through the simplification, we can see that right at this point. And then if you look at the graph, you can do this by hand or use your calculator. You can see the domain was from -3 to infinity, and the range is from 0 to infinity. The range didn't change, however, the domain did. Domain was from 0 to infinity for y is equal to the square of x. Now when I shift this to the left, the domain would be from -3 all the way to infinity now. And we can easily verify all these by hand or use your graphing calculator. We want to repeat part A for this new graph. Y is equal to cube root of minus 8x plus 8. And then you want to compare it with y is equal to cube root of x. Again, at first, it doesn't look obvious. That's a shifting. However, if I factor some numbers, that appears that it is indeed a shifting method can be used for graphing this. If I factor a -8 and move that out, then this would be cube root of minus 8, which is -2, times cube root of x minus 1. As you can see, here you're shifting that graph 1 unit to the right, and then this negative would show that would be reflect the graph across the x-axis, and this 2 shows that factor by -2 with the stretch vertically by factor of 2. And then, as we said, this is going to shift to the right 1 unit. This is x minus 1. So we can easily verify all that using the graph. As you can see, your graph does shift and stretch and reflect. And we can easily confirm all that by hand or use our graphing calculator. As you can see, the domain would be from -infinity to positive infinity for both of them. Sketch the graph of x minus 1 to the power of 2 plus y plus 2 square equal to 9. Anybody remember what does this graph look like? It's graph of what? What is that? Nobody? We did that before. What is this? What is x squared plus y squared equal to r squared? What is this graph? It's a graph of what? Circle. Yeah, graph of circle when the center is 0. This is also graph of circle. This is x minus h squared. When the center is not at 0, the center would be at h and k. Plus y minus k squared is equal to r squared. So that is the graph of circle. They're giving you all the information. You know the center would be 1 and -2, and the radius would be square root of 9. So we have all the information. I'm going to locate my center. My center is 1 and -2. And from here, I'm going to move the square root of 9, which is 3, up, down, right, left, and then I can recover my circle. This would be a graph of circle when it's not at the center. If the radius is 3. The radius is, you see, this number is r squared, right? So r squared is equal to 9. So r must be equal to plus and minus the square root of 9, which is plus and minus 3. But we're going to use 3 because it has to be positive, right? The radius has to be positive, right? So if this equation was not given to us in that form, do you remember what we did with that to get into that form? We used what? What method? We did that several times in class. Completing the square. Remember, we have to complete the square, make it look like this, and then graph them like we're doing here. So the equation of a circle centered at the origin with the radius r is found by finding the distance from the origin to a point x, y on the circle. So the radius would be, this would be distance formula. Square root of x minus 0 square plus y minus 0 square. And if you simplify that, you recover the equation of the circle. So the circle is not a function. So imagine a semicircle on top and another circle at the bottom. So really circle consists of 2 semicircles, one at the top and one at the bottom. And we can actually use this fact in our graphing calculator and enter two functions there to recover the circle for us. Solve y. When you have x squared plus y squared is equal to r squared. If I solve for y, so what happens? I get y squared is equal to r squared minus x squared. If I subtract x squared from both sides of the equation, and then y would be equal to plus or minus square root of that. So y1 would be plus square root of r squared minus x squared. That's one top of the circle. And the bottom one would be y2, which would be minus square root of r squared minus x squared. So if you go ahead and enter those in your calculator, you would see what happens to your graph. So in this case, when we have x squared plus y squared equal to 4, if I solve for y, similarly, get y is equal to plus and minus square root of 4 minus x squared. So we have two of them. If I graph these two on the same graph, y1 square root of 4 minus x squared and y2 minus square root of 4 minus x squared, you can see you can get this entire circle. When you use the calculator in function mode to graph this circle. So we need to do some calculation here. We have to obtain the graph, write the equation as two root functions. Okay, how do you do that? You need to solve for y. Let's go through all the steps. To solve for y, I need to isolate y. So here I have y in this term here. I'm going to leave it alone. I'm going to move this term to the right. So I get 9 minus x minus 1 squared. Then in order to eliminate this square, I need to take a square root of both sides. Would be plus and minus of that. And then to solve for y, you subtract 2. These would be my two equations that I enter to my calculator. If I enter these two equations in my calculator, you get your circle. You get half the circle at the top and the bottom, and then that would be your whole circle. Sketch the graph of x is equal to y squared minus 1. So what is this? What kind of parabola is this? I know it's a parabola because when one is a square and the other one is a square, is a parabola. When I have y is equal to x squared, this would be a parabola that open on what axis? You guys remember? If you have y is equal to, if the x is a square, the parabola opens on y-axis and going up. Now, if I have it the other way around, if I have x is equal to y squared, this would be the parabola that opens on x-axis. So if it's y is a square, the parabola opens on x-axis. If x is a square, the parabola opens on y-axis. You may want to write this on your summary sheet. It's good information to know. So in this case, this is the parabola that opens on x-axis. And if I write down the equation for those, you can recover that. If x is equal to 0, y is equal to -1. Just need some points here. If x is equal to 3, y is equal to -2, and so on. And then you can see clearly that would be the parabola that opens on x-axis and looks like it's shifting to the left 1 unit. And that would be your vertex. Graph x is equal to 2, y squared plus 6x plus 5. And its axis of symmetry on a graphing calculator. So we need to complete the square because this doesn't look like a general equation of the parabola. If you recall, to complete the square, we need to eliminate the coefficient of y squared. We have 2 here. We need to get rid of that. So we are dividing each term by 2 here in this step. And then between these two terms, I can complete the square. So you would get x over 2. I'm going to move 5 half to the left. And you would have to add something to both sides of the equation to complete the square. To do that, we take the coefficient of y divided by 2 and you square it. Everybody remember that? You take the coefficient of y, when the coefficient of y squared is equal to 1, you take the coefficient of y divided by 2 and you square it. That gives you 9/4. That's why we need 9/4 to complete the square. We're adding 9/4 to both sides of the equation. So this would be complete the square right now. That would be y plus 3/2 times y plus 3/2. And then I can combine all these. So you get y plus 3/2 squared is equal to, then just simply combine these two together. I'm going to combine minus 5/2 plus 9/4 first. That give me 1/4, negative 1/4. And then now I can solve for y. So y plus 3/2 would be plus and minus radical this term here. I'm going to isolate y by subtracting 3/2 from both sides of the equation. And this would be my equation that I can enter my calculator to graph them. Y is equal to minus 3/2 plus radical x over 2 minus 1/4 and the minus of that. These are the two equations you put in your calculator, and then you can see the graph using this method.